Hi and welcome to Orleans Virtual Meetup number 11. Today we're joined by a few guests to talk about visualization in Orleans and the various options that are out there in open source to visualize what's going on in your silos. So I'm going to start off proceedings today with a quick tour of the Orleans dashboard, and then we're going to hear from Dan, who's going to talk about some other pieces he's working on, which I can't quite remember off the top of my head now. And then Roger at the end is going to talk about Orniscent, which is another quite nice visualization tool. So let's just pause this camera, and I'll share my desktop.
Hello guys.
Oh, hi.
Oh, hi.
You might need to mute your microphone. Can you all see my desktop hopefully now? Excellent. It says you can, so I'm going to trust that you do. Gutenberg, you might have to mute your mic because I can just see you. Great, thank you. Cool. So I think I started off the visualization thing a couple of years ago with Silomon, which was a Node.js based web app I wrote, which connected through to your table storage account that Orleans could write to, and it would show you the various stats that are stored in table storage. And a few people used it, but it never really got particularly popular. There's a couple of problems with it, like it doesn't really work if you're hosting it on-prem and you're not using table storage, and it requires you to trust me with your storage keys, which is probably not a good idea. And you needed to sign in using Windows Live or Google, and it was a bit difficult to host yourself and everything else. So it never really took off, and it's kind of abandonware now. But it paved the way for dashboards to come, and more recently I've been working on a dashboard called the Orleans dashboard, which instead of being hosted elsewhere is hosted within your silo. So the kind of original motivation for writing another dashboard was from Service Fabric, having seen their dashboard with some envy and thinking we really need something like this in Orleans. And so I kind of started the project with three kind of core aims. Firstly, to have lowest possible developer friction to starting up and getting this thing going. Second was to have a kind of read-only view where you could do no harm, but you get a really good insight into what's going on inside your silos. And thirdly, I can't remember what the third one was. Never mind. It's going well. Thirdly was to have an aggregate view of the world. So you only ever consider the sum of all the parts rather than focusing down on individual grains. So to install the Orleans dashboard, it's very simple. You just install the NuGet package, and then it's a single line of code to register it with that extension method, and you're going. And I've got a kind of test host here which I can start up, and I'll basically show you the different parts. Because it's contained within Orleans, it's basically a bootstrap provider which this method registers, and then it hooks into some interceptors, and it starts an HTTP server inside the bootstrap provider, and then that marshals HTTP calls onto the Orleans thread context, and then into grains, and calls various grains to retrieve data about what's going on in the silo. So we can connect over HTTP onto port 8080, and we can see the dashboard. All the HTML files and JavaScript are all resources in the DLL, so there's no external configuration to do, or no IIS to host or anything like that. It's all done for you. So the idea with the dashboard is you get a really good overview. So you can see I've got 240 activations, and this graph will slowly build up as more grains get activated, and you can see the breakdown of what types of grains are active. So these blue ones are either ones provided by the system or the dashboard itself, and then you can see this is a grain that I'm using to test. How many activations there are of that, how many requests per second are going to the grain, and how long the latency is on average for each request. And then if I scroll down, I can see how many silos. I've got 3, and they've been steadily building up, and I can see what they're called and what their uptime is and whether they're active, and I can see the split of activations across the silos, so I can see they're all fairly evenly loaded. And down the bottom here I've got a new piece which is stolen straight from Service Fabric, which tries to show you how your silos are distributed across fault and update domains. So because this is just a test system on my own environment, they're all in the same zone. But if you're hosting in Azure, the virtual machines would be spread across fault zones and spread across update zones. So when a failure happens or when an update happens, it only affects a portion of your cluster at a time. So that's quite a nice way of kind of visualizing that and seeing where each of the servers are. So I can go in and click on this stuff. So if I click on a silo, it gives me some nice little graphs, and I can see the CPU, memory, and grain utilization. Grain utilization is kind of something I've invented to say what percentage of your grains are being actively used, and I think Orleans gives you 2 numbers. It kind of gives you the number of activations and the number of grains that it thinks are being used. So that gives you a percentage of your activations. What is the working set? I don't know whether that's a useful metric or not, but it'd be interesting to hear from people to see what they think. And then I've got some counters exposed and some of the properties of the silo exposed, and then it's quite a nice table down here which shows you which are the activations in this silo. So you can see this one. This is the primary, and it's got things like the management grain in it. If I go and look at other silos, they all just have activations of the test grain. And then you can drill into grains as well. So as you can see, for my test grain there's almost 500. I suppose there will be eventually 500, I think. And how many requests per second are going to it and how quickly it responds. And I've got a couple of graphs to show you each method on the grain. So example method 1 has a small latency introduced for every call. So latency is the orange line, and then the number of requests per second is the purple line. So you can see the latency is around 10 and 20 milliseconds, and you can see the number of requests is hovering between 5 and 10. And then example method 2 is very low latency because it doesn't do anything, but it has the same number of requests. So it takes a bit of reading and getting used to the graphs, but it hopefully gives you some kind of insight as to how the load is on each grain is split amongst the methods. And then you can see how is this activation spread across the various silos, and you can see they're distributed fairly evenly. So this whole thing is a work in progress, and I want to add more graphs and more charts and make it more useful. But I'd really like to do that with people's feedback and ideas and kind of drive it to something that people want rather than just my playing around with it in my spare time. So that's a whirlwind tour of the dashboard. You can find it on GitHub on the Orleans contrib site, and please contribute if you have some ideas. It's all React on the front end and fairly simple C# on the back end. So are there any questions before we move on to Dan's talk?
Hi, it's Jakub. What's the overhead for the system in order to support the dashboard? So how much, let's say, how many percentages of CPU is it using on the silo to actually get all those statistics?
Yeah, that's a very good question.
To ask the same thing.
All of it, yeah. Every spare cycle. I found that Chrome spends far more of my CPU time rendering these charts than any of the silo side pieces. Um, so up until the last release that I did yesterday, all of the dashboard was passively collecting data from grains kind of out of band, and it was just pulling stuff from the management grain. And I don't believe that was having too much of an effect. And then yesterday I released a version which introduces interceptors to intercept every grain call. And I'd really like some people to do some code review on that, actually, because I've done it in a way in which I think will have minimal impact, and it just uses an interlocked increment to increment the counter for every call, and another one to increment the amount of time spent on every call, and then out of process there's out on another thread it then submits that total every second, I think it is. So it's not like it's going and doing some kind of major processing on every call. I've tried to kind of minimize that, and I wonder whether that's an option you want to turn on or turn off. But the honest answer, Jacob, is I haven't really profiled it to get an idea of the overhead. There will be some. The observer effect is that you change the thing you're observing by observing it. But hopefully I've tried to do that in a way to minimize it. But yeah, using caution in your production environment.
Yeah, definitely. But you're not seeing like 10-20% overhead by running it. If it's half 1%, 2%, that's perfectly fine. But if you're suddenly taking out a whole core to get all those statistics.
Yeah, I'm certainly not seeing that kind of overhead now. It's very minimal. Looking at my
cool.
process list here, Skype for Business is using all of it.
I mean, have you tried to show in the dashboard any logging or exceptions? Because for me that would be really interesting. Not just the method calls, but also the success and the number of errors for those method calls.
That's a really good question. No, I haven't attempted to do that, and perhaps that would be an interesting addition to add on. Yeah, it's difficult to know with something like a dashboard where does the dashboard end and where does logging start, and a mechanism for browsing and viewing logs. And I don't know. I want the dashboard to remain a fairly visual thing. So if we can put errors on as a red line on the chart or something, and perhaps have a summary of the top 10 errors or something, that would be a really interesting thing. But I don't see it getting into too much more than that. But yeah, very good idea.
Just the indication of number of exceptions per method or per grain, just to be able to see that, I have actually some problems with the grain of this type, and then I can go to my logging solution to look for the details. So this is more just like a red light to tell me that there's something wrong going on, and then I can go to my logging and check individual problems.
I think that's an excellent idea, and I'll add it to the backlog, and contributions are welcome.
No problem.
Any other questions before I hand over to Dan?
Yeah, I've got one, just a quick one. That the update domains, how is that being detected?
The management grain reports what update zone it thinks is in. So
okay, based on Service Fabric specifically.
Yeah, I think it's an artifact of being in Azure, as my understanding.
Okay.
So I think that the Azure utils will report the update zone, but I asked on Gitter, how can I set the update zone or update domain so that in this example here I can have a better table, but no one was really too sure. So I need to do some digging into exactly how that works internally. But if anyone does know, it'd be nice to fabricate some here. Cool. Dan, would you like to take over? I'll hide my desktop.
Sure.
If I can figure out how to do that. Stop presenting. There we go.
So we're working?
Yeah, you're presenting now.
Okay. All right. So my focus in looking at this is coming from the perspective of being on an Orleans project that's had some peculiar constraints. One of them being that we had to run an Orleans cluster on premises, or at least be able to. So it was also necessary to be able to run entirely on premises, disconnected from the internet in some circumstances. So that really pushed me away from being able to lean heavily on some of the great existing analytics solutions that are currently available. But then as I started trying to examine how we were going to measure what was going on in the cluster to really get a good sense of what was going on, we found that there are some nice advantages to tracking things so closely to Orleans. The main one is that you can track things with a higher degree of resolution than you could by logging or publishing information to a remote destination. So really, the important thing to me is be able to measure things, be able to count things, be able to increment and decrement values. And that includes things like we were just talking about exceptions. When a grain method is called and an exception is thrown, we can catch this in a plugin in an extension to Orleans that I'll be describing here. So it occurred to me that there are many different places where metrics have to be captured, where logging has to be done. One of them is in grains. Another place is within an extension to Orleans. There are Orleans clients that share a logger and have access to tracking metrics. And so I kind of wanted something that would work everywhere within an Orleans cluster. So, what are some of the benefits of having access to more detailed information? You get a better, more holistic view of this distributed processing, analysis of patterns, isolation of problems. It becomes a lot easier to troubleshoot difficult distributed processing scenarios. So what do we do with this information? Well, we monitor it and great tools like the Orleans dashboard and some of the others that we'll see today. And visualizing it is very important because the metaphors that we use, the way we understand the data in our systems depends on how we can visualize that. So the richer information we can collect, the better this is. Of course, it's important that we don't introduce too much overhead, but when I started building this metrics capturing extension, the intention was we'd use it in our development environment, in our QA environment, and that potentially we would turn it off. But we found that it actually has so little overhead. It really is in the 0.5% or 1% of CPU. And we've actually changed our plans to keep it in the production environment and use it as a tool to troubleshoot real production issues. So I still have it in an alpha designation on GitHub, and I'll show you where that is. It's called Orleans Telemetry Consumers Metrics Tracker, and it's now in the Orleans Contrib collection of GitHub projects. I have some instructions on getting started with it, how to configure it, and I'll show you that in Visual Studio. But basically, the idea is we're going to use Orleans built-in telemetry APIs to track metrics, and this extension captures all that, keeps track of all the metrics on each silo, and also forwards the silo-specific counters and metrics to a centralized cluster metric screen. This consolidates, sums all the silo metrics, and produces a stream, a virtual stream that you can subscribe to. So I'll show you how that works. So here, I'm inside the Orleans host wrapper, and we're initializing the Orleans silo here. I also have the Orleans dashboard, simple stream provider, the usual sort of plugins here. And here's where we're registering a new Bootstrap provider for the metrics tracker. If we go to the program startup, we'll see how this is used. So once the Green client connects, we are going to get a GUID empty key. We use a GUID empty key to get the cluster metrics green. And then we call the configure method on that green, passing in a metrics configuration object. And I'm showing here the default options explicitly. Here, we're actually explicitly turning on exception counting and counting of method green calls. And the reason this isn't default is because this adds an additional silo interceptor so that all calls to greens will get intercepted by the metrics tracker, which otherwise, if you don't have these, either one of these is true, it won't set up an interceptor. Here you can specify your streaming provider name that it will use to publish those metrics. And we're going to show that. We'll launch it right here. And as that's starting up, I'm going to show you when we receive a new metrics snapshot, we're just going to write that to the console. And that metrics snapshot looks like this, very well documented here in XML comments. The time that it occurred, where did it come from, how many silos are represented in the data, because you can get either a cluster metrics snapshot or a silo metrics snapshot. If you want to look at things in more detail, there are two different virtual streams being published. And that's just converts it into a string so we can view it. And let's see, it should be running now. So now every time we're receiving a snapshot through this virtual stream, we're just dumping this data directly. And we can see some silly names in here, boop and poof. That's just part of the demo. But then we've also got, we don't have exceptions. I don't see any exceptions in there. But we've got some counters of things that are happening. And this can be custom. So when I found the Orleans dashboard, I, of course, immediately installed that and started using it. And then I thought, well, okay, this is great. This tells me the resource utilization. It tells me how many grains are activated. But it wasn't giving me any real specific, system-specific metrics. So my idea was to help extend the Orleans dashboard and hopefully help to enable other visualization tools by providing a way to capture and keep track of your system's custom metrics. So the other part of this was I started out building a mobile app to complement the Orleans dashboard. And as soon as I ran into this issue of realizing that I really wanted my own custom metrics as well, I shifted focus to this project. But this works. It's an alpha now. I'm going to do some updates in the next couple days to make it use the Orleans 1.3.0 that was just released. And, hopefully this is useful. And if you have any ideas for other features you'd like to see in a metrics collection library like this, please let me know. I'm looking for ways to make it more useful.
Dan, it was one of my original aims with the Orleans dashboard to allow you to include your own metrics and extend it with your own data. So I think I'd really like to integrate with your work there and let that be the mechanism for capturing the data and then publishing your own stats to that stream would then just automatically create new graphs, hopefully on the dashboard, if we can figure out a good way of doing that. So
Yeah,
yeah,
absolutely.
yeah, it looks good to me. Any other questions, or should we hand over to Roger?
I was just going to say the same thing that you said, Richard. I think it's really nice that that's been componentized or modularized in such a way that it can be used by any other sort of visualization system. It's quite obvious that there's two kind of major concerns here. One is how to visualize things, but another one is how to efficiently collect relevant data. So yeah, that's just a positive comment, that was all.
Yeah, I actually have a comment as well for them. Man, it's a great work. When I first think about the telemetry APIs, I was thinking on capturing data from the silos and push back to whatever system is outside the silo in order to process that or draw some visualization. But you did the opposite. You had actually capturing data on the telemetry APIs and pushing back to the silo again. So you can react, other brains can subscribe to that stream and react based on the telemetry data. That was a really nice sketch, man. Congratulations.
Thank you. Yeah, I definitely didn't want to tie it into a single visualization. I wanted to open it up and enable others to. So I'm glad that came through.
Yeah, it's a great work.
I fully agree with Roger and Gutenberg. It's really nice to have the ability to add your own logic and basically subscribe to that virtual stream of metrics. So I envisage being able to create some logic for automatically managing my clusters in case of some business metrics going up and down. So I see that it can be used not only for infrastructure, but also possibly for more application logic.
Absolutely. I think that, yeah, at a low level, there are some possibilities, and we've had some really interesting conversations in the Orleans Gitter channel about using this sort of data to make decisions about where to activate grains or all kinds of other optimization opportunities. But I think probably the lowest hanging fruit is being able to capture, like you said, the application specific metrics, the things that are the KPIs and things like that.
Precisely.
I've also been using it in doing functional load tests of Orleans systems, where I'll generate a bunch of work in a simulator grain, and I'll count up a bunch of metrics to track that work that I've produced. And then as the work gets processed in one way or another, I decrement the count. And if I end up with 0, I know that all the work that was supposed to be done got done. So you can do some big, at large scale, did we drop the ball anywhere?
That's a nice idea as well.
Cool. Thank you, Dan. That's really good. Roger, do you want to start your presentation now?
Okay, I'll just try and share it.
All right. We can see it now.
Okay.
That's
okay.
Good. Yep.
Cool. Okay. So this is another tool which attempts to rationalize, I guess, what's going on in Orleans. We called it Orniscient. We develop it at the company that I work at. So a number of developers have put a lot more code into it than me. I noticed my name against it in a previous slide. That's not accurate. It may be my idea, but certainly there's other developers here who do more work on it than me. It's a visualization tool for debugging and monitoring Orleans apps. There's two components: a proxy assembly, which you add to the silos of your cluster, and there's a separate web application which you run remotely from the cluster. We called it Orniscient because the idea was to look into Orleans, so we just combined two words to come up with one that we didn't get any Google hits on when we typed it in. We built this tool to attempt to visualize or rationalize what we're calling the grain space within one or more Orleans clusters, and understand how Orleans works and reacts to various scenarios. We've been working closely with the Orleans team to validate and ship the meta-cluster functionality, specifically the queued grain initially, and so we wanted to make sure that the tool could visualize multiple clusters within a meta-cluster at the same time as well, or multiple silos at least within one cluster, sorry, and we would use two of the tool. We could point the tool at more than one cluster, but not two at the same time. Another sort of goal was to simplify interactions with Orleans clusters without building a costly kind of user interface each time, and of course to ideally make it work for any Orleans application. So the deployment scenarios that we have for this particular tool, we think it could be a good learning tool because it kind of tries to visualize the cluster at quite a granular level. We've also been using it internally for developers and technical QA to interact with the cluster and visualize it. And we're also putting it in production as well, alongside our live clusters. And we've also used it as well when trying to explain the Orleans model to developers that aren't familiar with it. And we're hoping to put it in a Docker container so it becomes a bit simpler to execute on a local machine. And we also think that maybe it could be useful for visualizing what's going on in a standard Orleans application from any demonstration purposes. So one potential scenario could be from a documentation perspective. So here is a demo of a cluster that I made earlier. This is a scenario whereby a company wants to provide software to track bees in a hive. So this is very 5G IoT on a granular level. And I'm just firing up a cluster. And then I'm going to fire up the viewer. I'll explain later how they connect. Okay, so the tool's web-based, uses a JavaScript library called Visualize to draw graphs, and attempts to visualize all or a subset of grains within the cluster. Obviously, when the cluster's got quite a large number of grains, then it doesn't visualize each one individually. But if it's quite a small number, then it can. You can mouse over a grain, an individual grain, if you're looking at quite a small subset of grains, and you can see some information about it that you've elected to expose via Orniscient. For example, the role of this bee and the size of the bee. In this case, the bee is a queen bee. In this case, it's a worker bee, for example. The beehive doesn't have any exposed properties, and there's two beekeepers. The bee grains have a defined affinity to this hive. The mapping is defined by attributes on top of the grains at the moment, which I'll explain why later. On the right-hand side, if you click on a grain, then you can see some information about it. if you've elected to expose one or more methods from the grain, then you can execute that method within Omniscient. So if I wanted to invoke the register bees method on the hive grain, then I can create 3 more bees, which attach to the hive. Also, that method doesn't have a response, but if I was keen to check my honey supplies, I could invoke a method, and that could respond with an object as well of any kind, and that's shown as JSON at the moment. You can zoom in and out, so if you have a lot of grains, then you have that ability. On the left-hand side, certain properties that are exposed can be filtered on. So if I want to see, for example, all of the grains, but I only want to see for the bee grain the queen, then I can redraw the graph basically. And then I can obviously then zoom in on a specific subset of grains which maybe have a finite number. There's a summary view limit as well, which means that if I just reload this and I go to summary view, I might only want to see a maximum of 3 of the same type, at which point the graph will redraw a summary between the aggregates of the grains. So you can see here there's 5 total bee grains and there's 1 hive. So obviously that scales up to a large number of grains if needed. So that's the tool. The questions I guess that would be asked about it are why would you visualize in this way? So we did consider drawing edges in the graph based on the grain activation source. So when an invocation occurs which activates a grain, we could draw an edge then. But we weren't sure that would make it easy for humans to rationalize the system, given the general behavior of how Orleans works. An activation can occur from pretty much anything, and in a large system there's normally a number of types which can cause an activation of a given type, so the graph would be quite messy. So as one example there, if the queen bee grain activated the bee grain, you'd probably still want the hive grain to link to the bee grain rather than the queen bee. But we do feel that there could be value in visualizing it in that format as well as an alternative view. If you wanted to install it, you just need to upgrade your silos to 1.3, install the package, the proxy package, which installs the DLL on the silo, and then you can add the XML fragment to the silo configuration file to bootstrap it in. Some additional options that you can add. So by default, you just see a load of grains if you pointed it at your silo, but you can also add grain type filters to limit which grains are actually visible. Obviously, you don't want to probably see, you might want to, but you don't necessarily want to see the internal grains for the Orleans system, or there might be certain grains for other reasons you don't want to expose. You can invoke methods via the viewer if you put the Orniscient method attribute on the method. If you don't, then it's not accessible via the viewer. You can set up these links between grains by defining the affinity with another attribute called Orniscient grain, which you can put on top of the type of your grain, and you can set up client-side filters and grain tooltips as well, as you saw, and expose them via similar methods. We're going live with Orleans 1.3 next month with the metacluster functionality, and we're going to put Orniscient into production from then on. So we're going to continue to develop it and hopefully add more value to it, which I hope will be of use to others. Some of the ideas that we've got for it after moving to 1.3 are obviously to get it on .NET Core, put it into a Docker container so it's easier to execute without any deployment of a web application separately required. To optimize indexing, I know that there's a lot of work going on inside the Orleans team on indexing grains, so we're keen to leverage that. As I said earlier, a by activation view alongside a by design view would be great, so the ability to see a graph based on activation rather than based on view would be good for debugging. It'd be great to have a read-only mode for non-ops devs to access on production. So at the moment, if you've got access to Omniscient, then you can call all the methods that have been exposed by it. But it'd be nice to have an alternative view for developers who aren't allowed to actually modify production in any way. We thought it'd be quite good to create an embedded mode so that we could deploy this in a documentation space if needed or requested. Summary view at the moment doesn't allow you to invoke methods, so we need to add that. More speculative than that, we think it would be really nice to be able to actually design grain relationships with something like this. At the moment, when we design our actor-based systems, we find currently there aren't too many tools out there to help us to do that, especially in .NET. Some of the stuff that Dan just showed, I think, would be great to leverage in here. Eventually, even more speculative, it would be brilliant to do something with 3D, and hopefully, yeah, as I said before, it'd be good to work with the community to try and get more information out of the system and to visualize it in this way. And that's me.
Cool. I really like the visualizations you have, and looking forward to playing with an Oculus Rift as well. Has anyone got any questions for Roger?
Well, not a question, but I just want to say I think this is a fantastic tuning tool for people who are interested in Orleans and want to experiment with it and see what it's all about. I think this could be a first gentle introduction to these concepts. This is very cool. And 3D, I'm all about it. Yeah.
Yeah, I wanted to say something. I don't have a question, but all the presentations were really good. It's especially when learning, as some of you mentioned, like this is awesome. And yeah, at some point I think it would be useful to perf test it, or like at least know the overhead to know whether this is something that can also be run in production under heavy load or not. Like that would be useful to know, but definitely as a learning thing, it's awesome.
For me, the wow moment was the invoking of the method on the grain from the viewer. That's pretty neat. I have a question about it. How do you support any more complex parameters, or just simple primitive types at the time being?
At the moment, they're simple primitive types, but we've found that so far the methods that we want to expose to operations only have those. That may change, at which point we'd love to expose it, but also if anyone wants to contribute as well, obviously, by all means. That'd be great.
Yeah, that should be easy to make some kind of JSON form that people can just fill the key value pairs and initialize it to a method call. It should not be hard.
I know Ruben's on the call. I don't know if you're able to speak, Ruben, but you did something very similar, didn't you, where you were able to invoke methods on grains. Did you use a similar approach with sending in JSON, or did you just have simple types?
No, I was sending in JSON, but because I was using a command line console, the easiest way to do it was definitely just to send in primitives. So if you wanted to send in more complex types, you had to drop down to JS, so you could actually enter JSON.
So I think if that was added, then it would be really nice to keep the primitive, the safety of the primitive input boxes, if you like. So if it was a basic primitive method, then you'd have like 3 inputs for 3 integers, for example. Whereas you'd only want to express, I guess, your object with JSON if it was a complex object.
Not related to visualization, but kind of related to interacting with grains in an ad hoc manner. I wanted to plug Gutenberg's work that he created a PowerShell client to invoke grain calls and like to invoke great methods. I mean, so I don't know whether this could be plugged here, but it's something to keep in mind whether when you are tinkering with your clusters that might be useful.
That sounds cool.
By the way, I think that PowerShell NuGet, if I'm not mistaken, was released with 1.3.0 now.
Oh, that's good. I didn't know about that. Thank you.
I think I want to double check, but our intention was that, I think.
Julian, do you ever kind of get any requirements from customers about visualizing? I mean, and kind of second question, what did 343 do for knowing what on earth is going on inside the silos?
In terms of questions, I don't know. Most of those questions go through Gitter, and like any of us jump into, like mentioning these projects. In terms of 343 in particular, we actually are doing our own telemetry and using an internal Microsoft framework that gathers data, visualizes it, and whatnot. But it's something that unfortunately is not publicly exposed. But it's a mixture of all several technologies, like of course Hive, Cosmos, but the reality is that it's through telemetry events that each of the grains or whoever's interested just publishes to an external service through an ETW call. That's how it starts from, how it leaves the silo.
It seems one of the common solutions in industry is InfluxDB with Graphene, and I wonder whether that would be something interesting to get running on All-ins, to just as perhaps a walkthrough or something. You know, this is how to set this stuff up. Perhaps using Dan's stuff as an alternative to build a more rich dashboard than the one I've got.
There's also been some interesting work going on with traffic visualization, the live traffic between using Netflix Visceral library. And I think this is still work in progress. I think one of the requirements to really make it work is getting the caller information, not the callee information that we have, but the caller information in grain calls.
Yeah.
If we can collect that in silo interceptors, then we could do some pretty amazing live traffic graphs.
Yeah.
I think someone already suggested on Git how to get that. Maybe the interceptors could be used on the color itself. I don't remember about the discussion now, but someone already came with a solution for it, no?
Yeah, I think some suggestions were made. I think there was some back and forth about the best way to do it, or that we didn't want to send in the whole big object of stuff, and maybe just a couple details would get passed in instead.
Cool. Do we have any more questions or comments, or any other projects we should be aware of?
Well, just wanted to say that even if we are doing some telemetry sending to an external service, we actually did have to add a lot of plumbing code to diagnose slow methods or stuff like that. And this was before interceptors, so this would remove a ton of code. Like even if it's some of it can be just run on a test environment, that would be a great help. Like it would reduce the complexity of some of our grains.
What does a slow grain look like? Are you thinking just one-off calls that time out, or is there more kind of systemic, one method just gets slower over time kind of thing?
Well, basically, the one that resonated with something that we do like manually in a really bad shape, but it's the one that measures every single method, how long they take, and the latency. But at least how long it takes to execute, because in our non-reentrant grains, that's important, not just how much CPU it uses, but if like some of our grains like have a lot of messages in queued, and they start timing out, not because they take long, but because previous methods were taking longer. So that's kind of information that it's not really easy to diagnose at first, but with something like this that you just plug in and it works, like it's awesome. Like we had to manually, of course, have in every single, because we didn't have interceptor, but in every single method, like have a lambda expression that wraps everything and like measures how much it takes. I know that there are probably other ways to do it now that I understand the Orleans internals more, but because it was not easy, as this solution seems to be, like this would reduce a lot of effort and can help you immediately get the information that you want.
Yeah, when I look at the new Orleans dashboard and see the latency on that chart with the number of grain calls and the latency, that's a heartbeat. That's an EEG pattern that, when it's running, it's going to look, and it working correctly, it'll look one way. And when things go wrong, the human mind, the visual processing center, is able to see that kind of thing very easily.
Exactly. This bad solution I'm talking about, basically I ended up writing in some log somewhere that we then need to graph out separately as a separate step. Like this is just automatically. Yeah.
Cool. Pleased to hear it might be useful. Cool. Well, if there's nothing else, we'll wrap up. Thank you, Dan and Roger, for presenting and for your fantastic contributions.
My pleasure, and I'm looking forward to working forward with everyone going forward and keep pushing all the data visualizations that are coming out.
Definitely.
Same. Pleasure. And very much keen to talk about Dan about how I can leverage what he's done.
Indeed, yeah. Looking forward to working with both of you. Cheers, guys. Thank you for joining.
Thank you. Bye-bye,
Thank you
guys.
very much.
Cheerio. Bye.
Bye, everyone.